3.1 Simultaneous Equations. This is a new chapter that the whole chapter revolves around simultaneous equations. So the concept as a whole should be defined for you. And here's how it's defined. Simultaneous equations are two or more equations with two or more unknowns. So an example would be looking down here at x plus y equals 10. X plus y equals 10 is one equation, but it has two unknowns, an x and a y. This is another equation, our second equation, and we still have two unknowns, x and y. And while each one of those equations has its own relationship between x and y, their goal of solving simultaneous equations is to find the one point that the two equations overlap. So this one has its own relationship, this one has its own relationship, but I want to find out where are they the same. So I'm going to first look at x plus y equals 10, and I'm going to think this one through just using mental math. So I've got an x and I've got a y, and I'm going to list all of the points that I need that would satisfy this. Well, I couldn't possibly list them all, so I'm going to just list a few. 0, 10 would work because those two numbers add to give me 10. 1 and 9 would work because those two numbers add to give me 10. 2 and 8 would work. 3 and 7 would work. 4 and 6 would work. So I could keep going because there's actually infinite possibilities here, as I showed you in chapter 2. So because there are infinite solutions to this equation, it would be expressed as a graph, a line that was never ending. Here, I'm going to look at the relationship between x minus y. I'm looking at two numbers whose difference is 2. So could be 10 and 8. Could be 9 and 7. Could be 8 and 6, etc. So what is the one point that satisfies both equations? Well, let's think about this. Are there two numbers that when I add them give me 10 and when I subtract them give me 2? Well, I almost got it here with 4, 6, but that would be backwards and give me a negative 2. So actually, what it would be is that x would equal 6 and y would equal 4. And if you put a 6 plus 4 in here, you would get 10, and a 6 minus 4 in here, you would get 2. And the way to express your answer is as an ordered pair, 6, comma 4. Another way of looking at this would be if you had John has $30 and saves $5 per week, Sue has $90 but spends $10 per week. What week do they have the same amount of money? Well, first we're going to express our first situation, which is John has $30 and he saves, which means adds, $5 per week. Well, I don't know how many weeks. So if I were to define my variable, x would be number of weeks. Okay, so that's John. And then Sue has $90, but she spends, meaning minus, $10 per week. So that's Sue's money, and that's John's money. And I want to know when they're the same. Well, I'm going to spend a lot more time on that in mixture problems, which was later on in the chapter. So right now I'm going to move on to the next page to show you our first method, which is solve by graphing. So basically I have my two situations. I don't want to just think through it every time because Cindy's going to throw things at me that I can't just think through. So, and algebra just does that in general, and so does real life. So I need to have a method, and you're going to learn 3 methods. The first method is solve by graphing. So I'm going to graph each of these equations. I'm going to turn this into y equals mx plus b. So I'm going to subtract x on both sides, and I get y equals negative x plus 7. When I go to graph that, I know my y-intercept is at 7. 1, 2, 3, 4, 5, 6, 7. And my slope is negative 1, so down 1 over 1, and I know it's going to be this direction. And then I'm going to hopefully use my ruler tool right now to get this because it's very difficult to get a straight line with this pen. So there is my equation. Well done. Okay, so now if I go back to my other equation, I'm going to solve this one for y equals mx plus b. I'm actually going to move the y over because I don't like the y being negative, and I'm going to get x equals 1 plus y, and then I'm going to subtract 1, and I'm going to get y equals x minus 1. My y-intercept is negative 1. My slope is 1, so up 1 over 1. And then I'm going to use my ruler tool to give me this equation. See if I can move it a little to get it more perfect. There we go. Okay, so now I have my two equations graphed. And now I'd like to figure out, well, what point do they overlap at? Well, can you see it? It's right there. So what are the coordinates of that point? The coordinates of that point are 1, 2, 3, 4, 1, 2, 3, 4, comma, 3. So my solution to this simultaneous equation is 4, comma, 3. So last example, I've got two more difficult equations. I can't maybe think through this solution. So first I'm going to enlarge my graph because I can tell it's a little bit too small. And then I'm going to basically have to solve each one for y equals mx plus b. So I'll subtract 2x on both sides, and I'll have negative 3y equals negative 2x minus 7. Divide by negative 3. Y equals 2/3 x plus 7/3. Messy. Now I've got subtract 3x. Oh no. I'm actually going to subtract 12. I like that better. Would have worked the other way, but messier. I've got 3x minus 12 equals negative 3y. Divide by negative 3, which gives me y equals negative 1x plus 4. I don't need the negative 1, but I'll leave it there for now. So now I can either estimate this or I can try to choose numbers that are going to give me whole number values so I can get this, but I'm going to go ahead and first I'll graph this one because it's a little bit easier. Y-intercept is at 4, x-intercept slope is negative 1, so it's going to be this way. If I use my ruler tool, get it just right. Okay, now I'm gonna estimate this one. Okay, so I've got 7/3. What's that? Well, that's 2 1/3. So that's going to be roughly here. And then I'm going to climb 2, rise 2, run 3. Rise 2, run 3. Drop 2 and back 3. And now I'm going to get my ruler tool and use that. And I can see that there actually probably is a whole number solution. Remember, the solution is the overlapping point. So what are the coordinates of that point? It looks like it's 1, comma 3. And that will be the solution to my equation. But this brings up a really good problem. What happens if I have these messy equations that everything's in fractional form? What if my overlapping answer, my point that the two lines share, is a fraction? Well, that's why we can't use graphing every time, because graphing does have an element of estimation if you're using fractions. So in 3.2, you'll use another method that uses algebra to get you there, and 3.3, the same thing. So for now, solve by graphing, and then we'll move on to more sophisticated approaches after this. Thanks.